Hey guys, I just wanted to answer a couple of your questions that you had from the warm-up here, so I'll post this as a video so you can refer to it if you want to. So one of the questions came from Annika, who asked if the cotangent of theta is undefined, what does it mean when you're given a restriction on theta? So theta, treat theta like your domain. This is still a domain restriction because that's the input of the function, right? So what this tells me is that I need to keep my x value between pi over 2 and 3 pi over 2. Or essentially, the angle has to be somewhere on this side. Okay, so when we think about cotangent being undefined, well, we know that cotangent is the cosine divided by the sine. All right. So if I think about the points here, that if I'm getting an undefined value, that means that sine has to equal 0 because I want to divide by 0. And the only place that that happens is at pi, right? So that would tell me that the point -1, 0 is the point I want to use to find the other values they're asking for. But because cosine's -1 and sine is 0, that gives me a value of undefined. If they didn't put this restriction on, then we could have picked the point 1, 0, right? That would have also given us the cotangent being undefined. So all that's really saying is where to choose your angle between. So it's just like if I said, 3 is less than x, which is less than 5. Well, x has to be between 3 and 5. They're just saying your angle has to be between 90 and 270. All right? And this information also has to be true. Hopefully that cleared that up. Oops, sorry. Bennett asked if we were given an angle that's obtuse, how do we actually find the values? So let's say if I'm given an angle such as this that lands in quadrant 2, what you want to do is just build a reference triangle from that. So take where the angle ends, and you're always connecting it down to the x-axis, all right? And your reference angle, theta prime, is closest to the origin. So if our obtuse angle was maybe actually 120, right, over here, then the reference angle would be 60 degrees, or 180 minus 120. And we could do the same thing. Let's say our angle was in quadrant 3. That's really the angle. If I want to find the values, I pull it up to the x-axis and I get a reference angle. All right? And you're making those reference triangles. Same as if it were in quadrant 4. This is my angle. That's like maybe 300 degrees. Here is my reference angle. Okay? Sienna asked about finding the measures of the sides. So the only time, and the relationship between the sides and the angles, the only time the side length is necessarily 1/2 is when we're looking at something on the unit circle, with 30 degrees or 60 degrees. But, excuse me, if we're given multiple sides of a triangle, we can use, if you remember, SOHCAHTOA to find those angle values. And we haven't done a ton of this since quarter 1, but let's say we have a triangle set up like this. We know theta is down here. I could set up, because I know all 3 sides, sine, cosine, tangent, or any of those 6 trig functions. I set up sine here, which is opposite and hypotenuse, right? And my unknown, my missing piece, is theta, is the angle. So if we want to find the angle, then we would take the sine inverse of the sine of theta, and then the sine inverse of the other side of the equation as well. So it's just like I'm squaring both sides or dividing both sides. I'm taking the inverse function of both sides. Well, sine inverse and sine cancel, so we just get theta. And then sine inverse of 3/5, we would need our calculator. So 3, oh no, go away. 3 divided by 5 is 0.6. And then we want second sine, or the sine inverse. So here I have to push the shift button and then that. So we get 36.9 degrees, it looks like, just by putting that in my calculator. And I do have to make sure that I'm in degree mode, not radian mode. That's really important. All right. And one other question from Trevor. How do I find tangent when I'm given sine of 90 minus x? Oh, actually, I should make these the same, sorry. So remember, if you see something like 90 minus x where the angle is, that the cofunctions are equivalent. So the sine of 90 minus x would be equal to the cosine of x. And so we could find that easily, or we know that the the tangent of x would be equal to the cotangent of 90 minus x. So as this problem stands, we don't have enough information to actually find, if we have sine of 90 minus x, we can't just find tangent of x. But if we had both sine and cosine, we could. So I know the sine of 90 minus x gives me the cosine of x, and tangent of x is equal to the sine of x divided by the cosine of x, right? So I could find that from there. The other thing that I know is that sine of x squared plus cosine of x squared is equal to 1. So actually we do have enough information. I lied. So sine of x we don't know, but cosine of x, let's say, I don't know, the sine of 90 minus x is 3. All right. Well, then the cosine of x would also have to equal 3. So right now I have tangent of x is equal to the sine of x over, 1/3. Over 1/3. So I would replace cosine of x here with 1/3. And then sine of x squared, treat it like it's just x squared that we're solving for. So I'm going to leave that. I'm going to square 1/3, which is 1/9. And I'm going to rewrite 1 as a common denominator, so as 9/9. So here we get sine of x squared, and if I take away 1/9 from both sides, I get that it's equal to 8/9. And then take the square root, and we get the sine of x, that just canceled out the power of 2. Square root of 8 is 2 square roots of 2, and the square root of 9 is 3. So there we have the sine. And then if I wanted to find tangent of x, we would have the sine, which is 2 square roots of 2 over 3 divided by 1/3. That's what we had as the cosine. The denominators of 3 cancel out, so we just get 2 square roots of 2, right? That problem was a little bit complex there, but the main takeaway is that if you have the complementary angle, it's equal to its cofunction's complement. All right, so the sine of 90 minus